Good day, students. Today, the lesson is the law of cosines. All right, and the law of cosines, there are actually three formulas for it. Um, and what we're talking about is we have some kind of triangle that we want to solve. We have angles A, B, and C. We have sides A, B, C, the lengths. And it turns out that if you write a squared equals b squared plus c squared minus 2bc times cosine of a, then that is the formula for the law of cosines. Now, this only works when you have side angle side, where you're given two sides in the included angle, or you're given all three sides. So if you're given two angles, angle side angle or angle side, those are law of sines. And then of course the ambiguous case, angle side side, where the angle is not the included angle, that's also a law of sines case. But these two cases always are law of cosines. Now, because we could relabel all these sides, you can basically rewrite the law of cosines in two more different methods. What I want you to recognize, if you were trying to memorize this, is the side squared equal to is the angle on the other side. And finally, the last one is c squared equals a squared plus b squared minus 2ab cosine of c. So those are the three formulas. I try not to worry about those too much. I just really have this one here memorized, and I know that the other ones follow the same pattern. And so that's enough for me to be able to use it for any problem I want to use it. Okay? So let's go on and let's do an example of each case. Now again, your calculator has to be in degree mode because generally these problems are given in degrees. We have a equals 2 and b equals 3, so we can proceed forward. So we start to draw this. In this case, the angle is C. So I always start with the angle first. That's 60 degrees. But I'm not given side C. I'm given side A is 2 and side B is 3. So those are the sides that I'm given. So this is the side angle side case. So I can go ahead and do this by law of cosines. Now, what I want to first find is I want to first find side C. So that's the one I put over here, C squared, the missing side. So I go C squared equals A squared plus B squared minus 2AB cosine of C. And so now C squared is equal to 4 plus 9 minus 12 cosine of 60 degrees. Now, cosine of 60, that's a special angle, so I can just, that's 1/2, so I can just do that without a calculator. But I then get C squared equals 13 minus 12 times 1/2. And at this, since that's going to be 13 times minus 6, that's equal to 7. Then I have C squared equals 7. So C is equal to the square root of 7. And I only need the positive square root here because I'm solving for a length. So C is now the square root of 7. At that point, to solve the triangle, you now can do a law of sines to get one of the other angles. So I can do sine of C over C equal to the sine of A over A. And that'll be the sine of 60 degrees over C, which is the square root of 7, is equal to the sine of A, which I don't know the angle, over side A, which is 2. So I can solve this by cross multiplying and dividing, and I get 2 sine of 60 divided by the square root of 7 is equal to the sine of A. Now, this I can happen to do because sine of 60 is a special angle. So this becomes 2 times the square root of 3 over 2 over the square root of 7 equals the sine of A. And then that becomes the square root of 3 over the square root of 7 equals sine A. So the inverse sine of square root of 3 over the inverse sine, square root of 3 over the square root of 7 is equal to angle A. So if I can figure that out on a calculator, then I can go from there. So second inverse sine, square root 3 divided by square root 7 is equal to 0.71 radians. So now I got to change my mode because I forgot to change my mode. So, and this is a very typical thing. You want to be kind of aware of that as that happens. So now I can go back to the screen and press enter, and I get 40.9 degrees. Okay. Now, we were lucky on this one because it had a special angle, but I'll show you another problem a little later that doesn't have a special angle, and we will work through it from that point. So we now have two angles. We have angle C and angle A, and so now we need to find angle B. So we take 180 minus 40.9 minus 60, and that's what, 100.9. So we get angle C, or not angle C, angle B is equal to 79.1 degrees. And that's the last one. So now we have everything. Okay? Now, if you get exact angles, make those substitutions because they're better than decimals. And you'll get a more exact answer all the way up to this point. But now let me show you a law of cosines where we don't have a special angle. So we now have three sides. So this is the side case. So in this case, you can pick any one of the law of cosine formulas. It doesn't matter which one you pick. It just means you will solve for one of the, you'll solve for whichever angle for the formula you pick. And I tend to pick this one and then fill it in. So I'm going to have 16 equals 9 plus 36 minus 2 times 18, 3 times 6, cosine of A. So now I got to solve for the cosine of A. So I have 16, and I can subtract 9 and subtract 36, which means I'm subtracting 45 over here. So we'll do that first, and we get a negative 29 is equal to negative 36 cosine A. So then we divide both sides by negative 36. And so we get 29 36s equals cosine A. So now we can take the inverse cosine of 29 over 36, and that will be equal to angle A. And so the inverse cosine, again, make sure your calculator is in degree mode for these. The inverse cosine is equal to 36.3 degrees. Okay? So now I have used the law of cosine to find one of the angles. So now I want to find a second angle. So I'll use a law of sines. So we're going to do sine of A over A equals sine of B over B. So the sine of A, that'll be sine of 36.3 degrees over A, which is 4, equals the sine of B over 3. And then cross multiplying and dividing, we end up with 3 sine of 36.3 degrees over 4 is equal to the sine of B. Okay? And this is where you start to have issues because I've already got an approximation here. So if I do this and then take the inverse sine of a rounded off decimal, I get approximations of approximations. So what I'm going to do here that's a little different because there wasn't an exact value is I'm going to do the inverse sine of this whole thing. And this is what I want to enter in my calculator. Okay? It'll lessen the round off error that we've already introduced into the problem. All right? And it's perfectly fine to do it this way. My wife said dinner's ready, so I have to leave after I do this problem. So sad, guys. And so this is going to be equal to 26.4 degrees, and this will be angle B. So now we have angle B, we have angle A, so now we can get angle C. 180 minus 36.3 minus 26.4 is equal to 180 minus 6.3 minus 26.4 equals 117.3 degrees. All right? And we have now solved this triangle. So that's pretty much it. That's how you do it. So we're going to move on and we're going to focus on applications tomorrow. But this is really your whole lesson on law of cosines. This is how it's done. All right? The real trick, I should mention one thing here. The real trick to doing these is being able to decide, is my situation an angle side, an angle side angle, a side angle side, or a side side? So those are the first things I look for when I'm doing a problem. Do they give me two angles in one side, or do they give me two sides in one angle? These are law of sines. You use law of sines to do these all the way. These here our law of cosines, but to do the second part, you use the law of sines. All right? So these use law of sines for parts 1 and parts 2. These use law of sines for parts 1, but the second part will be law of sines instead of law of cosines. Then you have what is generally called the ambiguous case. All right? And that is angle side side. And if you spell a bad word, that means you got to watch out. And that's the way I always remember it. So this one you have to think, gosh, what is that height? What is that height? And you got to compare that height to the length of the floppy side that can swing. All right? And then also compare the floppy side of the triangle. Got to compare the floppy side to this side over here as well. And if it's longer, you only make one triangle. If it's shorter but bigger than the height, then you make two. If it's exactly the height, you make one right triangle. And if it's shorter than the height, you make none. So that's the ambiguous case. So that's the stuff you need to remember on law of sines and law of cosines. Okay? Alrighty, good luck. Enjoy your practice. Make sure you practice enough so you got it.